Hey, thanks a lot. Really appreciate that. I assume folks can see the slides and the audio is good. Okay, cool. Thanks for taking the time to spend with us to learn a bit more about Google Cloud. I'm going to do a quick intro. My name's Greg. I've been at Google now. Sometime this summer will mark my 8 years, and that time is entirely in Google Cloud, which 8 years ago in cloud is somewhere around the Paleozoic era, I think, in terms of the pace at which cloud seems to be evolving. My name is Greg. That's my Twitter handle if you want to follow me and engage in conversation there. I want to spend the next 45 minutes giving you what will inevitably be a bit of a whirlwind look at Google Cloud Platform. It's an incredibly broad platform with a lot of capabilities. I am not going to be able to cover every feature, every service, every capability. I'm trying to focus on the ones where I think we have some unique value that we can add. And I assume that you're familiar with the basics of cloud and cloud economics and all that sort of stuff. But before I dive into the specifics, I just want to do a little quick mental test. When I say the word Google, what's the first thing that comes to your mind? It's probably this, right? That first quintessential Google experience. Type some text, 400 milliseconds later, the World Wide Web is searched and you're given an answer. When I look at this experience though, after having been here now for 8 years, I don't just see this incredibly simple UI. What I see is what powers that. And what powers that incredibly simple experience is a deep set of infrastructure. And when I say infrastructure, I mean that in a broad sense. I don't just mean servers, although certainly there are a lot of servers. I mean hardware, software, network, operations expertise, all of that we first built for search, we then went on to use to build, as Ron said, 8 other services that have 1 billion monthly active users. And in a sense, what cloud is taking that expertise, that infrastructure, that software, and making it so it's not just something Google can build on, it's something anybody can build on. Now, I hear what you're probably thinking at this point. That's great. I'm not trying to build Gmail. And you're right, you're not trying to be Google. You're trying to be the best bank you can be, or the best manufacturer, the best insurance company. Maybe you're a startup trying to disrupt an established competitor. Maybe you're an established company trying to fend off disruption. What I want to do in the next bit of time is to give you a sense of how this platform we built can help you, whether you're a small company or a big company, whether you've been around 5 years or 50 years, and regardless of what industry you're in. Now, as I said earlier, it would take me all day to go through all the capabilities, and thankfully I don't have to, because you have speakers like Mede and Brian who are going to come after me and go into detail. So I'm going to focus on sort of 4 big bucket theme areas where Google Cloud has, I think, some unique capabilities. I'm going to highlight a few sort of key services that are part of that. And along the way, I'm going to tell some stories about some customers who have used us. The first area I'm going to touch on is infrastructure modernization. This is the ability to take what you're currently doing, whether that's in another cloud provider or in an on-prem environment, and securely and reliably run that on Google infrastructure. And along the way, figure out how to save money, increase reliability, increase security. The second area I'm going to talk about is databases. It's no secret that probably the most important thing you do with all those servers you have is you run databases. They power your business in some form or another. So I'm going to touch a bit on how we can help you use both commercial, open source, and some real Google special sauce databases to help you get better, more efficient, more results out of your database systems. The third area I want to talk about is analytics. We keep all this data in databases so that we can make business decisions. So I want to talk about some of the tools we give you to unlock the value that's in that data. And that would be my normal alarm clock going off, but I'm already up. And that will include the ability to use artificial intelligence techniques that we first developed for our consumer businesses at Google, and how we can help you with that. And last thing, I'm going to talk about application development, because you don't just run third-party software. You run software that you've developed yourself. So I'll talk on how we can give you the ability to easily build, integrate, and manage, that's important, applications, even if they don't run on Google Cloud, even if they run in your on-prem environment or, God forbid, another cloud environment. So with that, let me jump into the first kind of big bucket area, infrastructure. And this is in some ways the foundation of everything we do, right? Because ultimately, software has to run on a server somewhere. So how does that work? Well, let me start with a true statement that might be a little uncomfortable for some folks, which is that the vast majority of companies cannot differentiate themselves based on how well you operate infrastructure. You can't be a better bank by getting better at laying network cables. You can't be a better manufacturing company by being better at patching operating systems. Put another way, great job maintaining our DNS entries, said no CEO ever. So, but then sometimes that people make the next leap, which isn't quite right, which is, although most companies are not differentiated on their ability to operate infrastructure, Google is. Because we started so long ago, 20 years ago, and because we've had to build up expertise in order to support all those billion user consumer services, we have had to develop the ability to operate infrastructure in a unique way, in a way that does differentiate. And when you build on Google Cloud, you can sort of inherit a lot of that differentiation. Okay, what does that mean? What kind of differentiation am I talking about? Let's start at the core level of actual physical infrastructure and network. By the way, all the photos you're looking at are actual photos from Google data centers and other Google facilities. We care so much about this, we like them to look pretty on the inside too, as I like to think about it. So let's start at that core network and infrastructure layer. Of course, it starts with compute regions. You need compute capacity everywhere in the world. And of course, like most cloud providers, we do that. We continue to spend billions of dollars every year putting more compute capacity in more places. Unlike at least one other cloud provider, however, we make sure that every region from the time it opens has 3 independent failure zones in it. These are important because independent failure zones are portions that have independent power sources, independent network sources, independent connectivity, with the idea that being, if you're trying to run your business, you need to be resilient even in the face of natural disasters or other sorts of events that are outside your control. So capacity around the world. Now, we tend to focus on the computers and the data centers, but there's another part of cloud infrastructure that's equally important, that's the network. And again, if you think about it, in building out our consumer side, in order to make YouTube work, we needed lots of network capacity all over the world. To watch a YouTube video in high definition, or to make Gmail accessible around the world, we needed a lot of network capacity. And so many years ago, we began investing in our own private backbone, our own private fiber optic cables. We even went so far as to become the first non-telecommunications company to build and operate our own subsea cables. The photo on the left is one of the trawler ships that's laying a deep sea cable. The bottom right is, I think that's one of the Asian cables being brought on shore. And the top right is one of the cables surviving a shark attack. Don't worry, we wrap the cables in a substance that's, as you can see, is resistant even to sharks. The result is those regions around the world are stitched together by Google-owned and operated network backbone. And this is really important for a couple reasons. One is it increases security because most cloud providers treat network capacity as something they want to get rid of. They turn it over to whoever's cheapest. The result is, for most customers in that case, lower latency and a less secure environment because you have no idea what intermediaries your network traffic is going through. We, in the vast majority of cases, carry network traffic from a Google data center across a Google-owned and operated fiber directly to the ISP of the end user. In a B2C scenario, that's the ISP literally of the consumer wherever they are in the world. In a B2B scenario, that is network traffic being delivered directly to your on-prem environment or your customer's on-prem environment. So we think the network makes a big difference in terms of your ability to create very reliable services. Turns out PayPal agreed. PayPal is a Google Cloud customer, and for them, when they were coming on board, this network was a key reason for them to go with Google Cloud. And if you think about it, it kind of makes sense, right? PayPal's in the checkout flow. That is the moment where if you really don't want things to go wrong, if a PayPal checkout has a hiccup, the customer abandons the cart or they go to another form of payment, either of which are bad for PayPal and bad for their customers. So their SVP and CTO explicitly called out the network as a key driver for their choice of Google Cloud. Let me go and talk about, and again, I apologize, this is by nature a bit whirlwind because I want to get through a lot of stuff. Let me turn to VMs because those of you who've operated VMs in an on-prem environment, there's a tendency to think that all VMs are the same, that a VM is a VM is a VM. And I want to motivate some thinking to suggest that's not the case. In most environments, you think of a VM as a slice of a single computer, right? You have a rack in your server and it's got, I don't know, 60, 120 cores in it, and it's got how many gigs of RAM, and it has a NIC. And what you get is you get a little slice of that server. You get a certain number of its cores, a certain number of its RAM. We think of a VM as slightly different in Google Cloud's data centers. We think of a VM not as a slice of a computer, but it's really a slice of a data center because it's not limited by what you can fit into a single server. It's a slice of a very large pool of CPUs. It has access to a very large pool of GPUs. It has a slice of a petabit per second bisectional bandwidth within a data center. It has access to custom hardware that we're going to talk about later in terms of machine learning and AI. It has flexibility because it has access to a very large pool of high-speed disk. So a VM, you should think about it a little bit differently than you might normally think about a VM. Let me give you just 3 quick examples of how that comes out. First, most cloud providers provision VMs in fixed sizes, 2-core, 4-core, 8, 16, 64, whatever. No enterprise workload requires exactly that many cores, and no workload requires exactly that much RAM. The result is you always are overbuying. Every time you provision a VM, you are buying more than you need because you need 42 gigs of RAM and 10 cores, but you can't buy a VM with 10 cores and 42 gigs of RAM. We have custom VM shapes and sizes. We can take this very large pool of cores and RAM, and we can provision you exactly the size you need. In fact, we actually proactively can tell you when your VMs are using much less than what they're provisioned for. And in the console, with a click, we will resize your VMs down. Customers on average save about 19%, just flat off, just from that. So custom VMs. Second, we tend to think of GPUs. If your mental mindset is a physical server, you think that there's whatever GPU is in the server is in the server. And so most clouds, they give you GPUs tied to specific machine sizes. If you want the best GPU, you're going to get the best CPU. That's not the way most workloads work. There's an awful lot of workloads that need massive GPU, but frankly, don't need much of anything in the CPU. And so again, people tend to over-provision. We allow GPUs to be attached to any machine type. So you can get the best Tesla K80 GPUs, and you can attach them to just a bog standard CPU. And the last way that I want to talk about is around disks. Again, if you're used to thinking that a disk is something that's in a server, you can't change its size very easily. Our disks, our persistent disks, though, are stored off server and connected with a very high speed network, which means that they can be, they're like a little mini SAN, but without the hassle. What does that mean? You can resize a disk as your needs grow. So it turns out you provisioned a database and it turns out you're running out of disk space. You can pause the machine, resize the database, restart, and now you have a bigger disk. Disks can automatically be shared. So you can have one writer and multiple readers. They can this is really cool. They can automatically be replicated for disaster recovery. So all of your writes to a disk, a persistent disk, can be automatically replicated to another facility. And so they're always there ready in case of a disaster recovery. So taken together, and I think Brian's going to talk about this later, it's helpful if you shift your thinking on VMs to not think of it in terms of what you're used to in an on-prem sort of environment, because really these compute engine VMs are much more flexible and much more capable than what you're probably used to in other clouds or in an on-prem world. Let me touch on security, because this matters to everybody. If your data is not secure, then it kind of doesn't matter where it is. And again, having grown up in the cloud, we've had a front row seat at Google to the evolution of security threats. From the very, very early days when it was the script kiddies who just wanted to make a name for themselves and deface your website, up through criminal organizations looking for financial and credit card data, all the way up to nation states engaged in active espionage hacking. We've seen it all. And so we've had the luxury, in a way, of being able to harden our systems as we go. Whereas if you're starting from scratch now, you just get the full brunt of all the security issues that the internet can bring with it. So how have we responded to that? Let me start with an observation. Most enterprises, certainly, and I would say even a lot of cloud organizations, think of security this way, in this picture. You've got something really valuable. You put that thing in a castle. You make sure the castle has really thick walls. You put a moat around the walls. And it's all based on the idea of keeping the bad actors outside and keeping the valuables inside. But if there's one thing we've learned in watching all of the parade of breaches that have happened over the past 5 or 6 years, whether it's credit card data, corporate data, it's that this view, although companies think security looks like this, most of their security looks more like this. That wall is not nearly as thick as you think it is. And once you're inside, everything is soft and easily available. We take a very different approach. We don't take an approach, we don't inherently trust anything. We don't put all of our trust just in a perimeter-based security. We assume everything could be compromised. And if you take this trust nothing approach, you build out a very different security architecture. And we call it layered defense in depth. It's layered because you don't put your trust in any one layer. You don't just say the network separates trusted and untrusted network traffic. You assume that anything coming over the network could be good, could be bad. You don't put all your trust in any given piece of hardware or any given operation. So you apply security principles at every layer of the stack. Yes, you do security at the network, but you also do security at the hardware layer, at the operations layer, at the data layer. Second, defense in depth means you don't trust any one mitigation. You assume that any one mitigation might fail. So at every one of those layers, you apply multiple security defenses. People are surprised, but at Google, there's no VPN. There's no difference between a laptop connected physically inside a Google office and a laptop sitting in a Starbucks on a public Wi-Fi. All traffic from those two are subjected to the same security checks. What do we know about the machine? What do we know about the user? What do we know about the network connection? It's delightful for us as Googlers because literally I don't hassle with VPN software. As long as my laptop has a network connection, it has a Google certificate on it, I have access to the services I should have access to. So this layered defense in depth means that we think about security quite differently. Let me give you a couple concrete examples. Those of you who've operated virtual infrastructure know that underneath all this VM magic, there's a hypervisor. And a hypervisor is software, and software has to be patched. It's one of the fundamental laws of computing. But patching a hypervisor means taking down all of the VMs that are running on that hypervisor. And that's a customer visible downtime. Now that could be a little annoying if that's a stateless front-facing web server. That could be a real pain if that thing that has to be taken down or rebooted is your SAP instance. And customers tell us all the time, you get notices from a cloud provider saying, hey, you'll need to reboot this system sometime in the next week or two. That's because they're doing maintenance on the hypervisor. But that leaves cloud providers in an awkward place. They want to patch frequently, but the more frequently you patch, the more customer downtime you have. So they tend to defer those sorts of maintenance. We have a technology called live migration. Live migration allows us to take a running VM, move it from one host to another with no downtime. Its IP address stays intact, its memory stays intact, all of its persistent state stays intact. The result is we can do more frequent host patching and maintenance because they're not customer visible events. In fact, when we were developing this system and testing it, we had some customers ask us, hey, when are you going to test out that live migration thing you told us about? And we told them, go look in the logs. Like, we did it a dozen times yesterday. You didn't even notice. And this works on even our largest VM sizes. So even a 6 or 12 terabyte RAM VM, we can live migrate in order to do maintenance. That means that you can get more up to date with less downtime. Let me put all this together for you into a real world case where we had to respond to a security threat and how all these pieces, layered defense in depth and live migration, came together. You may remember Spectre and Meltdown. Spectre and Meltdown were a set of vulnerabilities not in software, but in the fundamental instruction set architecture of modern microprocessors. You may not know that it was discovered by a Googler. So part of layered defense in depth is we have a team called Project Zero, which actively searches for vulnerabilities that nobody knows about to find them. Because if we can find them before the dark web finds them, we in the industry can mitigate them. So that's one part of defense in depth is we actively search for vulnerabilities. Second, we developed a novel mitigation. At the time, everybody thought Spectre and Meltdown would cause a 30% performance hit. Think about that. How much computers do you have? Go tomorrow and buy 30% more to keep your performance. That's obviously a pretty scary event, certainly scary at the scale of the number of computers Google has. So we developed a clever technique that involved modifying the C compiler. Part of the defense in depth is we staff a team to maintain the C compiler. We then recompiled our core infrastructure software, redeployed it using live migration. It meant that every single GCP customer was patched with zero downtime. In fact, most of them were patched before public disclosure. So by the time you read about Spectre and Meltdown, if you were a GCP user, you were in all likelihood already patched underneath at the hypervisor level. This is where it all comes together. It's not that we knew Spectre and Meltdown were coming, but because we take this trust nothing layered defense in depth approach, we were able to respond to help customers. Okay, that's a whirlwind tour of infrastructure. And again, I could spend hours on that. Let me quickly talk about data management. Put simply, we have fully managed versions of all the big databases you would expect. So if you're running MySQL, PostgreSQL Server, Redis, HBase, we have fully managed versions of those that not only get you out of running the infrastructure, but get you out of even having to patch and manage the database. But I want to focus one in particular on one particular problem of running databases at scale, and that's mission critical SQL. It turns out, any of you who've tried to maintain and run a large scale mission critical SQL database it's hard. Scaling is a pain because you either have to do scale up, which means provision an entirely new database, copy all the data over, make the storage work, or you try to do scale out, and that involves super complex sharding layers, which make operations more difficult. Then you have the pain of operating a mission critical SQL database, indexes, managing those, patching, updating. Replication, you face the challenge of transactions. Like, you use SQL because you want strong transactions, but you know that doing that hurts your performance and makes scalability difficult. And we went through all this as well at Google. And so we developed a unique to Google offer that we use ourselves, and we call it Spanner. Spanner is a SQL database, but it solves the problem of scaling SQL. And it does it because it is SQL. Like, you have schema and you have SQL queries and you have strongly consistent transactions. So it has all the goodness you want out of a SQL server, but it scales horizontally. And that means literally, if your SQL database is running out of room, with Spanner, you go into the console, you make an API call, or you make a command line, and you literally just add capacity, and that's it, you're done. And it's fully managed, which means it gets you out of the pain of having to figure out how to make SQL run at scale. It's also, and this is sort of a nice little payoff to that. I talked earlier about our investment in the network and in the data center. Spanner is, what makes Spanner possible is hardware in the form of atomic clocks. We put atomic clocks in each of the data centers. It's that network that connects those data centers together that enables and makes Spanner possible. Then it's some clever software, and then it's sort of the operational expertise. So Spanner's the kind of thing that even if you wanted to run in your own data center, unless you had a network of the capability that we've built out, plus the ability to put atomic clocks into your data center, you wouldn't be able to get the same result. And we see this with customers. Optiva is an ISV, they are a SaaS ISV, and they provide software to the telecommunication cell phone industry. And they noted that Spanner was 10 times faster and reduced their costs by 10-fold in terms of operating their core financial service that actually figures out how to charge customers, which, as you can imagine, is about as mission critical as it gets. So on the database front, we can offer you the traditional databases you're familiar with, Postgres, MySQL, et cetera, and we can offer some fairly differentiated capabilities around things like Spanner for mission critical SQL. And I apologize, I know this is whirlwind, but I want to give you sort of the big building block pictures about Google Cloud. Okay, let me turn to analytics. And I'm going to give you another sort of unpleasant fact that is true, and we probably all know is true, but still is unpleasant. Most of us spend an awful lot of time taking care of the machinery around our analytics. We spend more time taking care of the data warehouse than we do looking at the data. And surveys bear this out. Harvard Business Review said in a study that less than 1% of unstructured data is ever analyzed. So unstructured data, emails, documents, spreadsheets, well, not so much spreadsheets, but emails, documents, voice recordings, all the stuff that your office workers tend to interact with. Less than 1% is ever analyzed. Now, I can hear what you're saying. Okay, fine. That's most of my mission critical database, though, is in a database. It's structured data. Well, the survey wasn't much more encouraging. Less than 50% of structured data is ever used to make a decision. Think about that. You're managing all this data that you do that because it's critical to your business, and less than half of it is ever used to make a decision. Well, what are you doing with it then? And we thought about this. Why is it that we have all this data, but it shows up so little in our decision making? And we think the data warehouse is really the bottleneck. Most data warehouses, and this is even true of cloud ones, you spend a huge chunk of your time and money not on analysis and insights. There's one cloud data warehouse, even today, where the first step when you're provisioning it is to tell the provider how many cores you want and how much storage and RAM you want. We think you're already on the wrong track if the first step of your process is to think in terms of physical servers. So in the same way that serverless development, app dev, is so popular, we think serverless analytics has, for all the same reasons, adds a lot of value in terms of a data warehouse. If you can eliminate the need to think about the server and allow the user to just think in terms of the fundamental primitives, in this case, data and queries, you can eliminate a whole bunch of that overhead. And our solution to that is called BigQuery. If you ask any Googler, I think most of them would say that BigQuery is probably BigQuery is probably the product that most enables Google to be Google. It's the thing that we all use internally. It's the way we gain insights on our customers, on our markets, on our infrastructure. We use BigQuery to query server logs to find out about failures in software and hardware. It is an enterprise data warehouse. It can scale from small databases all the way up to quite literally exabyte scale databases and individual queries processing petabytes of data. All that data is automatically encrypted, it's automatically redundantly stored, and it's kept highly available. But the real value is that it is fully managed and serverless. What that means is quite literally, you simply upload or stream data into BigQuery, and then you write a SQL query, and that's it. That's all you have to do. You don't update anything, you don't patch anything, you don't index anything. BigQuery takes care of all that. It also works on both streaming. It embraces this emerging notion of real-time analytics. I think the days of the nightly, weekly, quarterly business report are over. I don't know any business that's interested in getting a report that said 3 months ago something happened. I can't do anything with that. No retailer wants weekly summaries of sales. They want to know sales trends as they're happening. BigQuery enables that because you can stream new data in real time into BigQuery, and that data immediately appears in query results and in dashboards, whether you're using Tableau or Looker or whatever visualization tool you're using. And in fact, we see the result. Telegraph Media Group is a UK-based media organization. They migrated to BigQuery, and the same team size, what used to take 2 hours to do in terms of analytics, literally they do now in 8 minutes. And from my point of view, the kicker is this thing about zero infrastructure management. Nobody at Telegraph sits there and worries about how to patch or maintain their data warehouse. Nobody worries about how to shard storage. They just write queries. BigQuery also has one of the most loyal individual user communities I've ever seen. So it's not just CIOs and CTOs that love it. If you go to Twitter, BigQuery has some of the best fans in the world. Justin Carmody was commenting that querying 1 billion events, parse the data, save it to a new table in 37 seconds. Graham Polly, sorry, I had to bleep out the word after holy, but you can imagine what it is. He was noting the fact that because BigQuery is fully managed, we continuously roll out improvements, and he just in one day saw a massive performance improvement in his queries to the point of he had a 4 terabyte query that took 16 seconds. And of course, Spotify has been a big user of BigQuery, and when we went public with Spotify as a Google Cloud customer, one of their data analysts tweeted, "Finally, I can tell the world that BigQuery is the best thing that has ever happened to me." It's a magical piece of technology, and I know we're all sort of trained to be, cynical, analytical people, and so it almost reads like, yeah, whatever. But honestly, people who try BigQuery, you immediately get the value. It's a great starting place if you're thinking about your journey into the cloud. Often the data warehouse in BigQuery is a place where you can get the fastest bang for the buck back from your efforts. Okay, so BigQuery helps you write queries that you already know how to write. AI helps you answer questions that you don't even know how to ask. And our goal here is to take AI out of the realm of only for the Stanford MIT grads and into something that all developers can use. So how do we do that? Well, it starts by just recognizing that, again, on the consumer side, you've all been using AI-based systems for years now. Every time in Gmail that your spam is classified and it stays out of your inbox, there's a piece of AI that has done that. If you've ever used Google Photos and just done a search for birthday snow and gotten a picture of that time your kid's birthday party was on the day it snowed, or if you've used Google Translate back when travel was a thing, and you translated a sign from German to Italian, that was AI. So we've been investing in AI and machine learning on the consumer side, and along the way, we built up a common framework for doing AI, because when we first started, every team was rolling their own, and we said, this is crazy. And so some of our best engineers came up with a framework, and we called it TensorFlow. But then we went a step further and we shared it with the world. So TensorFlow is an open source framework that was originally developed by Google for use on our consumer products. It's now used by researchers, academics, even our competitors, because it gives machine learning experts a way to build and operate machine learning pipelines and run them wherever they want. Run them on Google Cloud, run them on another cloud, run them on-prem, even run them on a local device like a cell phone. Now, our use of machine learning was so large that we ran into a challenge of, how do you do this at scale? And we talked to other customers who were doing machine learning in fields like biomedical research, and they were running into the limits of what could be done with conventional hardware. So like anybody, like Alan Kay said, everyone who loves software eventually does their own hardware. We eventually did our own hardware too. You may be familiar with the fact that GPUs, graphic processing units, aren't just good for games. They're good for a lot of other tasks too. Turns out they're pretty good for machine learning too. But we realized that you could go further, that if you designed a chip specifically for TensorFlow, you could get a whole other step function of performance. And so that's what we did. We call them TPUs, tensor processing units. This picture here is a picture of our third generation tensor processing unit board. The second generation, those 4 copper things are the chips. The second generation units had about a 3-inch, maybe a 2 or 3 inch heat sink on top of each one of those, which limits the density of how much you can put in a rack. So the third generation that you see there is liquid cooled. Those colorful tubes that you see are carrying liquid cooling to the chips. It's our first piece of liquid cooled infrastructure in a Google data center. That made data center ops people a little nervous at first. So what these TPUs do is they are up to 27 times faster than a conventional processor. Not 27%, 27 times. And if you look at MLPerf benchmarks, they can be up to 38% cheaper for the same job because they're so fast, you run them for less time. Not only that, they can be connected together in what we call a pod. Basically, multiple of these boards are connected together with a high-speed memory interconnect between them. It's connected in a, if you want to get into the details, a toroidal mesh network. So things aren't just connected in 2 dimensions, they're connected in 3 dimensions to other boards. You put those together and you can literally get 420 teraflops for one of those and 100 petaflops when you put them together into a pod. That is absolutely supercomputer class performance out of something that you can rent by the hour. And in fact, we see customers like our pharmaceutical customers using these to dramatically reduce the time it takes to build and test new drugs. But that's for the experts. What about for folks who are just data analysts or app devs? How does all this fit together? Well, at the bottom, we have Google Cloud's infrastructure, all the stuff we talked about before, the data centers, the network, the VMs, the security. On top of that, we have TensorFlow and TPUs, so software and hardware specifically optimized for machine learning. For advanced use cases, that's all you need, right? If you're a machine learning expert, you can use machine learning engine and build and train your own models straight onto this hardware and software. We also have pre-packaged AI. So you remember all those APIs, all those consumer examples I talked about Translate and Vision. We've taken many of those and just turned them into REST APIs. So if you want to know what's in an image, we have a Vision API that takes our consumer photos service effectively and turns it into an API that anyone can use. But we realized there was a gap in between. There's a gap where people needed custom models for their domains, but didn't want to start from scratch. So imagine you want to build a model that can tell the difference between a defective manufacturing part and a not defective one. Well, that's a vision-like task, but no pre-built API is going to know that. And that's what we have in the middle. We call it auto ML. Auto ML is ML that creates ML. And if that sounds a little Inception-like, bear with me. But what it allows you to do is take your private data, easily build a model to work with that without having to start from scratch, without having to know anything about TensorFlow. And as a result, you get a private model that's only for you, that you use, that's based on your data. So what it does is it takes your private data set, it manages the process of training and deploying that model and serving that model. And the result is you go from your data to an ML system with a REST API without having to understand the details of machine learning. So for example, retailers can use AutoML Vision to tell the difference between brands of products by photo. Or manufacturers can tell the difference between auto parts without having to train from scratch. You can take your own custom jargon, industry-specific language, and build a translation system that takes everything we already know about translating French to English and adds your industry or domain-specific knowledge. And we do this for vision, translation, video, and tables and tabular data. And that's really important if you think about how much of our corporate data is in tables, is in spreadsheets, is in SQL databases. And being able to quickly make predictions on tabular data turns out to be really valuable. Pitney Bowes has a order processing gateway that takes international orders from customers. They needed to do fraud detection. They used AutoML tables to take their historical data and quickly predict which orders were going to be fraudulent. And instead of it taking 2 months for them to do it, they were able to do the whole process from scratch, build, develop, deploy in 2 weeks, without having to learn a whole bunch of special ML and AI skills. So that's kind of the analytics story. BigQuery for a serverless data warehouse, and then a complete range of AI solutions, whether you're already AI experts who want access to cutting edge hardware and software, you're just an app dev who wants to incorporate vision and speech and video into your app, or you're a company with proprietary data that you want to build a custom model on, but you don't want to have to staff up a whole team of experts. Okay, last section. So we started with infrastructure. We talked about data, databases, and I talked about analytics. Now let me talk about app dev. This is near and dear to my heart. I started my career as a software developer, and so this is very important to me. Let me sort of talk again and start with a maybe uncomfortable truth, which is cloud, for all of its benefits, can be hard. If you're coming from an on-prem environment, you're faced with relearning everything. You're also potentially faced with the possibility that not everything can go to cloud. Like some things need to stay on-prem, or they need to be on a factory or a cruise ship or on an oil rig in the North Atlantic. And then when you realize that, now you're faced with, I've got to have a cloud team and an on-prem team. And then my poor security people have to think out how to apply security to both these. And then another cloud comes along and it has a unique capability you want to use. And now you're thinking, okay, now I got to have 2 cloud teams and an on-prem team. And it gets to be challenging. And I think what it boils down to is there's a basic tension, which is, you need cloud to drive transformation, to drive the changes you want in your company. But at the same time, you know that complexity is the biggest source of difficulties. And so how do you embrace cloud while keeping the complexity under control, particularly when you're in a time of having to run in multiple locations, on-prem and Google Cloud, or hopefully Google Cloud, but in whatever cloud you run in. And that's why sort of hybrid cloud platforms have been so popular, right? You can sort of immediately get the appeal. But honestly, if you look at them, most of them have failed. So why is that? Well, we thought about that. And we think there's 3 key principles to doing hybrid cloud right. First, you need flexible deployment options. You need to be able to build an application as a developer, have your developers just think about app building. And then when they're done, be able to deploy that app on-prem or in whatever cloud you want. Like you've got to keep that option open. Second, we know that the solution has to be software-based and built on open source. Any solution that involves buying more proprietary hardware to put in your data center just furthers your inability to be able to flexibly deploy. And we know open source is the ultimate key to giving you freedom of choice and to giving you control in your own destiny. So whatever we do, it has to support deploying in lots of places. It has to be software-based and based on open source. And finally, and this is critical, it has to be at the right abstraction layer. Some of the early attempts to do sort of hybrid cloud platforms were fundamentally focused at infrastructure. The APIs were all based on manipulating infrastructure. We believe the way to do this is to build a system that abstracts away the infrastructure, that's focused on managing services, and then get clever about how you stretch that model back to incorporate your existing VMs. So how does all that come together? We call that Anthos. That's our platform for app development and modernization. It is built on open source. So it is a 100% software platform that builds on Kubernetes, Istio, and Knative to give you the basics of managing containers at scale. It also is a complete software platform. It includes things like GKE, Google Kubernetes Engine, which is our fully managed offering for running Kubernetes at scale. It includes a service mesh, and I'm going to talk a bit about what that does real quickly. I'm going to go real fast because I know I'm getting close to running out of time. What Anthos does, it allows you to take a variety of kinds of applications, container-based, VM-based, or third-party. It gives you a single control plane for deploying, configuring, and managing them. And it allows those applications to be deployed on Google Cloud, as well as on AWS and other clouds, and even into hybrid environments. It gives you the ability to immediately get critical data on your applications, like performance data. Immediately you can get a dependency graph of your services, which is something that many organizations struggle with. It allows you to create SLOs and SLAs and error budgets and to track how well you're doing on those. So immediately, even if you're not running in 3 different places, even if you're only in one place, Anthos immediately gives you the ability from an operations, the ability to do scalable so that you can do canary testing and run a new version of a service at 1%, 5%, 10%. My internet connection is unstable, says Zoom, okay. It also gives you the ability to protect services from bad behavior by doing rate limiting and access control. So you can say the payment service is only callable by the order processing service. No other service can call it. And you can do that by policy, and it guarantees that that's true. One of our banking customers went from deploying their core banking app from a quarterly basis to monthly to weekly. So that's a 13 times improvement in their ability to roll out their app. Last thing I want to talk about is app dev itself. Everybody loves serverless, but not everybody loves all the constraints that come with serverless. The fact that you can only use one programming language, one runtime, you can't use third-party libraries. We have built a serverless product we call Cloud Run. Cloud Run is everything you love about serverless, but it gives you all the flexibility of container-based development. So literally you can go from source code to running app in seconds. You can use whatever programming language you want. You can use whatever library you want. And then that app can be deployed on Google Cloud or in on-prem. The app scales up on demand, and really importantly in a time like today where who knows what tomorrow looks like, that application scales down all the way to 0. So if there's no API requests to your app, it goes to 0. And you pay on 100 millisecond increments of use. So it really is a great way to give you what you like about serverless, but in a flexible way. I'm going to give one shout out here. If you're a developer and you're just getting started with Google Cloud, it can be overwhelming the number of services we have. Our DevRel team has put together a great resource called the Google Cloud Developers Cheat Sheet. It's every one of our services described in 4 words or less, give or take. There's some hyphens and slashes there that I find a little dubious. If you go to this website, 4words.dev, it will take you to the GitHub repo where you'll find a poster version, desktop wallpaper version, JPEGs, PNGs, PDFs. It's a great way for you to sort of get oriented to everything Google Cloud has while navigating our great yet sometimes confusing marketing names. Okay, that's the end. So let me start back at the beginning. How is Google Cloud Platform different? 4 things. 1, we give you secure, reliable infrastructure built on our history of operating infrastructure at scale. We give you a range of databases from the commercial and open source that you're familiar with to some unique offerings that solve one of the hard problems about managing SQL. 3, we can help you unlock the data you have through a really clever data warehouse, as well as AI and ML solutions. And 4, we can give your developers and operators the ability to modernize existing apps and build new apps quickly and easily, and you get the freedom to run those applications wherever you want, on-prem, in the cloud, in Google, or in other clouds. So I'm right at 7:47, so I'm 2 minutes over, apologies. But I really want to thank you for taking the time. I hope that the rest of the day is really useful to you. You're going to hear from some of our DevRel experts on a lot of these areas and really drill deeper into some of the specifics of how they work. And so, like with that, I really want to thank you. Again, Greg DE, that's me on social media, on LinkedIn, on Twitter. Love to continue the conversation. And with that, I'll stop and I'll turn it back over to Rob.
Thank you so much, Greg. That was absolutely fantastic. I'm going to do a couple of things. First of all, I'm going to ask Juan Carlos, our key security experts, to start sharing his screen. That was a fantastic overview. I'm also going to want to do a couple of polls. First, I've just launched a poll. I'm curious, and everyone can respond back in real time, just wondering if you're currently a GCP customer. Not Gmail, all of us are pretty much Gmail customers, but who is currently using the Google Cloud Platform for their business application. And it looks like probably a third of you are current GCP customers, probably 2/3 of you are not. That is largely in line with the current marketplace, but I'm glad that we're able to expose many non-GCP customers the value of the GCP solution. Greg touched on a number of important subjects that we're going to go into much more in depth with each of the 6 subsequent speakers. I'm going to end this polling, and then I'm going to pull up a second poll here. One of the things I like to do after each presentation is just get your feedback. Are each of the speakers hitting the mark? Do you find the content useful? I like to get this real-time feedback so we at AngelBeat, in cooperation with all of our speakers, can make sure we're delivering the right information. I'll look at on my screen. Wow, this is fantastic. 96% all excellent or very good. That's just what I want to hear. Always good to get that immediate gratification.